This is just a reminder about the basics for a Bohr diagram. You always start with the element symbol. You have to provide the number of protons and neutrons that that element has. The period that the element is in is equivalent to the number of half circles you're going to be drawing. The first circle, or the circle closest to the element symbol, is the same as the first period. The last circle that you draw should represent only valence electrons. So let's take a look at the periodic table and pick a few elements and see what we can come up with. So I'm going to ask you to draw a Bohr diagram for lithium. Lithium, symbol is Li. It is in the second period. Okay, so it's going to have two circles, two half circles. The number of protons is equal to 3, and the number of neutrons is equal to 4. And I would know that by looking at my periodic table and looking at the atomic number, which is the same as protons. And to figure out the neutrons, I would take the mass, which isn't listed on this periodic table, but it is on the copies that you have, and I would take the mass and I would subtract the protons from it. And that's going to equal neutrons. Okay, so this one I happen to know that the atomic mass is rounded off to 7, so I'm going to say that the neutrons are going to be equal to 4. The first period is the one that's closest, so it's this circle right here, and it's full. If there's more than one circle, then this is full. There's 2 elements in that group, 1, 2, as you can see, hydrogen and helium, so that only can hold 2 electrons. The second circle represents, in this case, the number of valence electrons. Everything in group number 1 has 1 valence electron, so I'm going to write 1. These 2 numbers should add up to equal your protons, and they do. So that's one example of drawing a Bohr diagram for something like lithium. Another example we could look at might be, let's look at, for example, argon over here. Okay, so again, I'm going to write down the symbol AR. I know that the protons is equal to 18 because I saw that. On this case, the mass of argon is 40. So if I have 40 and I minus 18, I should get what? 22. So that's going to equal 22. And what period is it in? It's in 1, 2, 3, the third period. So I'm going to have 3 half circles around it. The first circle is filled. Remember, it can only hold 2 electrons, excuse me. The second circle is also filled. If you have more than 2, then the second is filled. And if I count all the way across, I can see that there are 8 electrons in that period. And the last circle, again, I'm just going to be looking at the number of valence electrons, and argon happens to be a noble gas, and it has 8 valence electrons. Again, if I add these up, they should equal 18, and they do. Now let's see if you can draw a couple of these on your own. Again, look at beryllium, Be, find it on your periodic table. Determine how many protons it would have and how many neutrons. How many half circles would you draw around it? So what period is it in? And the first period is always going to have 2, and the second period is going to be just the valence electrons that's above the group number, so that would be 2. So 2 and 2 is 4, and that's the same as the protons. See if you can do the rest on your own.